Okay, now we're going to talk about weather and climate, also things that you're very, very familiar with. So first of all, idea is that solar energy drives the cycle in Earth's atmosphere, and some of these cycles determine weather and climate. Okay, and we're in what they call a Maunder minimum right now, and that's why the climate of the Earth right now is actually cooling, contrary to what some people had been expecting. Clouds and precipitation. First of all, we have the hydrologic cycle. This essentially means you get evaporation from the ocean, transports it up into the atmosphere, condensation occurs, and then and precipitation happens. Then it comes off the land through rivers, streams, whatever, and goes back to the ocean. There's many smaller subcycles on this. The reason why they talk about it from the ocean rather than the individual lakes that you have or your cattle ponds is because oceans, of course, cover of such a large portion of the planet. So clouds form when air masses are cooled to their dew point, generally cooled by upward movement, convection, barriers, mountain ranges, for example, and colliding air masses with different densities. When they collide with quite a bit different, we sometimes get what we call tornadoes. Cloud formations depend upon atmospheric stability. So a stable atmosphere lifts parcel of air, the lifted parcel of air is cooler and denser than the surrounding air, and the lifted parcel returns to its original level. Unstable atmosphere, the lifted parcel of air is warmer and less dense than the surrounding air, so it's moved to higher levels and it will continue to rise. That's a thermal, okay? So what they're talking about is how temperature changes will cause changes in altitude with different parcels of air or clouds or whatever. So upward mobility and moist air. Rising moist air cools, eventually reaches its dew point, which is we talked about in the last chapter, and the droplets condense around condensation nuclei. No condensation nuclei, you get supersaturated air, and you don't get any rain. So you have to have some sort of a condensation nuclei for that to take place. The cooling of air of rising air slowed by the release of latent heat of vaporization. Okay, so the huge numbers of droplets appear as clouds. Now, where does rain come from? Well, it comes from up above, right? It's water returning to the Earth's surface. Dew and frost are surface processes, not precipitation. Okay, so dew and frost are not coming down from the sky. Precipitation forms in two ways: coalescence of cloud droplets and the growth of ice crystals. As we said, the next part is that water takes the place of coalescence processes. Takes place in warm cumulus clouds near the tropic oceans. Clouds contain giant salt condensation nuclei. Okay. The salt ice crystal process takes place at clouds of middle latitudes. Ice crystals capture nearby water molecules and grow. This falls as snow in the winter, melt and turn into rain in the summer. So the ice crystals are up above there. It's just dependent upon what temperatures they fall through in terms of what happens to them when they finally hit the Earth. Weather producers, or the idealized model is regions of 10 degrees north and 10 degrees south of the equator receive more direct solar energy. So that air heats up, rises, and spreads towards the poles. Air cools and becomes more dense as it rises, sinking back to the surface at latitudes 30 degrees north and 30 degrees south. So bands of low pressure near the equator, and there's bands of high pressure, and this is what this is the region of those trade winds that we talked about before. And once you get above these, you've hit sort of a null zone, above this one and below this one. You get the null zones where the horse latitudes are. They used to call them horse latitudes because the sailing ships would all of a sudden have to start. They would not have enough wind to progress very far, And so the horses would oftentimes die, and they would have to throw them overboard. And so when they got into those regions where their ships couldn't move, you saw floating horses around there. So anyway, the horse latitudes. You can look that up, and it's kind of interesting how that all, where some of these names came from. Large convective cells form to equalize the pressure, right? Air masses. Large horizontal uniform bodies of air. Moisture and temperature conditions are nearly the same. There's 4 major types. Continental polar, right up here. Maritime polar, up here. Continental tropical, that's down in here. And then maritime tropical, that's down here closer to the equator. Okay, so you got this version first, these up here, then you've got this, and then you've got these. This actually extends and over land, it's over a lot further as well. And these 4 main types dictate, our air mass weather is dictated by weather conditions remain the same over several days. Weather changes when a new mass moves in or when the air mass acquires local conditions. So finally, when those big cold winds come from up north, eventually they cool before they get to us. Likewise, the warm ones coming up from the south or from the coast all moderate as they reach us. Weather fronts, boundaries between air masses are at different temperatures. So here you have a high and you have a low. You've got a pressure zone from that. This is a cold front. It's going to be right here. You've got a warm front. This advances over the cooler air, right? These are longer, gentler, more sloping ones. These cold fronts are more circular and smaller in size, right? The moist air rises is cool, leading to large cumulus and thunder clouds. Okay? Stationary front is the forces from one balance are balanced by the other ones. So if you have a stationary front, that means that type of weather that's over you, you're going to have that for a while. The boundaries between air masses are at different temperatures. Okay, this looks it's right. Okay, the difference on this one right here were these type of ones causing the cloud formation with the warm air. And you see the cumulus type variety here, and then this variety here where the warm air mass air flows, and you get the cirrus type of clouds here. You've got cold air here, warm air mass over this. And so these two pushing together form this tall cumulus cloud. This right here forms these high cirrus clouds. Okay? Waves and cyclones. Bulges or waves often form between oppositely moving air masses. Overriding uplifted cold air produces a low pressure area. Further cold front motion leads to an occluded front and a cyclonic storm. Okay? Cyclones or tornadoes. Low pressure area with inflowing upward forced winds. The circulation pattern caused by a Coriolis effect, right? So this shows how the warm air here, the cold air here, at the front there you get a loop, and all of a sudden if it becomes too much, the occluded front, you then get the cyclone taking place and just destroying everything in its path. So an anticyclone is a high pressure area. The air sinks and is warmed, and its relative humidity is lowered. Okay? So you have the cyclone and the anticyclone. Major storms are rapid, violent weather changes, often associated with frontal passage. 3 major types: thunderstorms, tornadoes, hurricanes. Thunderstorms usually developed in warm, very moist, unstable air. So if you see the cumulus portion, this is associated with convection, mountain barriers, or a cold front. A mature one can no longer support the growing ice crystals and snowflakes, so this starts falling. And depending upon the temperature down here, it's either going to come down as rain or hail or ice or sleet or snow. And finally, all updrafts are exhausted, and all you get is just your continuous downpour. Lightning and thunder. Updrafts, downdrafts, and circulated precipitation occurs separate electrical charges. Separate. This is not, okay, so what happens is the charges accumulate in different parts of the thunderhead. The discharges between the charge centers. The discharge can be cloud to ground, ground to cloud, or cloud to cloud. Okay, this right here is discharge of cloud to ground, ground to cloud, and you have cloud to cloud here. Expanding pressure waves from heated air produces cracks of thunder. So tornadoes are the smallest, most violent weather disturbance. Rapidly whirling air, diameter 100 to 400 meters. Sometimes you can have a whole row of these that will just tear through a county. Wind speeds up to 480 kilometers per hour. Damage produced by high winds, the drop in the pressure, and flying debris, and yes, a single straw can be driven into a telephone pole. It's associated with intense thunderstorms. Hurricanes are tropical depression. They go through these stages. They start out as a tropical depression. It's an area of low pressure. Winds are generally moving about 55 kilometers an hour or less. Usually for us, these start off over the coast of Africa. As they move towards us, sometimes they become a tropical storm. This is more intense, low pressure area. Winds are between 55 and 120 kilometers per hour. Once they start getting to a shore, sometimes they get to a very intense low pressure. Winds are in excess of 120 kilometers per hour, and they fully develop. There's an eye, as you can see the eye right there, with this stuff going swirling around it at very, very intense rain and thunderstorms. You have the tropical depression. It's an area over a low pressure. Winds are generally moving at this particular one. A tropical storm, 50, and then a hurricane at these. So you get gale winds out here, hurricane winds right here, and here you have the quiet eye of the storm. Okay? Weather forecasting based upon mathematical models of the atmosphere. Billions of calculations necessitate the use of supercomputers, right? Fairly accurate forecasts, up to 3 whole days possible. So those who are trying to do it in terms of decades or centuries, I don't think the models are quite that good. Major uncertainty, insufficient technology to connect small and large-scale events. Ultimately, oceanic influences need to be better understood. And that covers 2/3 of the planet. Climate is a composite, large weather patterns occurring over a number of years, and it influences determine the type of plants and animals at a given location, type of houses built, your lifestyle. It will influence the shape of the landscape, the type of the soil, agricultural type, and productivity. Warmer places produce a lot more food. 2 primary factors: intensity of the incoming solar energy, determined by the angle of incidence and the number of daylight hours. Tilt of the Earth's rotation. Equatorial regions receive more incoming solar energy. Intensity changes on a yearly basis. The number of daylight hours varies throughout the year. Climate and latitude. Yes, there's different factors involved here. And then the climate zones. Near the equator, the polar climate, temperate climate, and rainfall patterns shift seasonally. And then the climate influences by altitude, mountains, as well as large bodies of water and ocean currents. And describing climates, the problem is there's no sharp boundaries. No two places have exactly the same. And what we're going to talk about here is the North American climate zones. And it has all the different ones listed here. I'm sure you're familiar with all of them. We are in this temperate region right in here. Okay? And then finally, these are the very specific definitions of each one, and you can review that and gain your knowledge from that. So microclimates, that's well, I think we're going to end there.